Question number 26. A soil depth has three layers having same thickness each, but the permeabilities of the layers are in the ratio 1:2:4 from top to bottom. What is the ratio of the average permeability in the horizontal direction to that in the vertical direction? So soil is in three layers. Okay. Soil is in three layers, and each layer of same thickness. Let the thickness of layer is h. So the thickness of second layer will also be h, and thickness of third layer will be h. Okay. Now, if the permeability of first layer is k, then the permeability of second layer will be 2k. And similarly, the permeability of third layer is 4k because this is in 1:2:4. So the KH, horizontal permeability, will be K1 H1 plus K2 H2 plus K3 H3 divided by H1 plus H2 plus H3. So K1 H1 K into H plus K2 is 2K into H plus K3 is 4K into H divided by H plus H plus H, that is 3H. Okay, so this is 4 to 6 and it's 7. 7 KH divided by 3H. So this is 7 by 3K. And KV, the permeability in vertical direction, is H1 plus H2 plus H3 divided by H1 by K1 plus H2 by K2 plus H3 by K3. So this is H1 plus H2 plus H3, that is 3H divided by H divided by K1 is K plus H2 is H divided by 2K plus H divided by 4K. Okay, so this is 3H divided by, if you add these three terms, then this is 4K. So this is 4H plus 2H plus H. So this is 3H multiplied by 4K divided by 7H. 7H, H gets cancelled out. So this is 3 by 7 K multiplied by 4. Okay. So now we have to find the what is the ratio of average permeating horizontal direction. We have to find KH divided by KV. So KH is 7 by 3 K multiplied by 7 by 7 divided by 3K into 4. So K and K gets cancelled out, and we have 49 by 36. So this is 49 is to 36. So option will be D. This is question number 26. Answer will be D, 49 is to 36. The answer is D. Next question is question number 27. A soil mass under seepage has a downward flow of water. Which of the following statements are correct with regard to stresses at any point in the soil mass? First statement is effective stress is decreased by an amount equal to seepage force. So the soil mass after seepage has downward flow. It has downward flow. Okay, flow is downward. So effective stress will increase. It will not decrease if flow is downward. This implies that effective force, effective stress, effective stress will increase by amount I into Z into gamma W. It will increase by this amount if there is no flow condition. Okay. So in no flow condition, if effective stress is sigma, okay, and if there is downward flow, then the effective stress will increase by this amount I Z into gamma W. Okay. So this statement is wrong. It is saying that effective stress decrease. This will not decrease. Effective stress will increase flow condition. Second statement. Effective stress is increased by an amount of equal to seepage force. Yes, this statement is correct. Total stress, total stress will change. Yes, total stress will change. This is correct. Total stress will be unaltered. So this is incorrect statement. This is incorrect statement. So 2 and 3 is the mm, 1 second. Give me 1 second. Mm, So actually, uh, this statement, actually, I'm very, very sorry. This statement is total stress will change. The total stress will be unaffected. This statement is correct. This is incorrect statement. I am explaining why this statement is correct and this is incorrect. So total stress, while while total stresses, total stress at a section at a at a section is is equal to equal to weight of soil is equal to weight of soil is equal to weight of soil, that is weight of solid weight of solid weight of solid plus weight of water plus weight of water plus weight of water at a section divided by divided by divided by area at that section divided by area at that section. So it is not affected by, so it is not affected by, it is not affected by, it is not affected by seepage force. Seepage force. So total stress is not affected by, total stress is not affected by seepage force. Okay. Total stress is not affected by seepage force. Only effective stress is affected by seepage force. And if there is downward flow, then it will increase by an amount of seepage force, that is I into Z gamma W. Okay. And second point is Seepage force act in direction of flow. Seepage force. Seepage force act. Seepage force acts in the direction of in the in the direction of in the direction of flow. The direction of flow, comma, when flow when flow is in downward direction is in down downward is in downward direction. Seepage force will act in seepage force will act in will act in downward direction. Downward. Seepage force will act in downward direction. And this will increase and this will increase. This will increase. This will increase the effective stress. The effective stress. This will increase the effective stress by an amount by an amount equal to equal to equal to seepage force. Seepage force. Okay. So effective stress will increase if flow is downward, and effective stress will decrease if the flow is in upward direction. Okay. But the total stress will remain the same because effective stress is equal to total stress minus U. If there is a flow, then there is a difference in the there is difference uh, in the pore water pressure. Okay, so if there is static flow condition, then at two points um, the U will be sigma minus U. So effective stress will this sigma will be unaffected, but sigma prime will decrease. Okay, so this is the option 2 and 4 is correct. So option number D will be the correct answer. Okay, this is question number 27. So question number 28. Consider the following statement. Organic matter increases the permeability of a soil. Organic matter increases the permeability of soil. No, this statement is wrong. Entrapped air decreases the permeability of soil. Yes, this statement is correct. So only two statement is correct. So option number 28, option number B is the correct answer. So I'm explaining here. Entrapped air has pronounced effect on permeability. Entrapped entrapped air has pronounced effect on permeability on permeability. It reduces it it reduces the permeability of soil. Permeability of soil. Okay, and organic foraging and organic foraging Organic frozen matter also has the tendency to to move move towards flow channel flow flow channel and and choke them and choke them, thus thus the decreasing the permeability. So organic matter decreases the permeative soil, not increases. It will decrease the permeative soil. So statement 1 is wrong. The statement 2 is correct. So option B will be the correct answer. This is question number 28. Now question number 29. Consider the following statement. The statement 1 is permeability of soil decreases as the effective stress acting on the soil increases. Yes, this statement is correct. As effective stress increases, this implies that void ratio will decrease. And as void ratio will decrease, this implies that permeability K will decrease because K is directly proportional to EQ divided by 1 plus E. Okay, so this statement is correct. Now statement 2. The presence of organic matter in the soil increases the permeability. This is wrong. I explained this in earlier question. Okay, so statement 2 is wrong. Statement 3. Entrapped air decreases the permeability of soil. Yes, this statement is correct. I have already explained in question number 28. So 1 and 3 statement is correct one. So option number D is correct. Okay, option number D is correct. So let me explain this again. So as effective stress increases, as effective stress increases, as effective stress increases, wire ratio decreases. Wire ratio decreases. Wire ratio decreases. Hence, hence permeability decreases. Permeability, permeability decreases. Okay. Now, organic matter has a tendency to move towards organic matter. Organic matter has the tendency has the to move towards to move towards flow channel flow flow channel and choke them and choke them, thus reduces permeability. Thus reduces permeability. Okay, and entrapped air decreases the permeability of soil. Entrapped air decreases the permeability of soil. Okay, so D will be the answer. Now question number 13. A sand deposit has porosity of this. So porosity is 0.375 and specific gravity is 2.6, and the critical hydraulic gradient for sand deposit is. So for critical hydraulic gradient, I ICR is equal to G minus 1 divided by 1 plus E. So this is G minus 1 divided by 1 plus E is eta divided by porosity divided by 1 minus porosity. Okay. So G minus 1 minus porosity, that is 1 plus 1 minus, this is not 1, this is 1 minus porosity plus N. Okay. So this is G minus 1 into 1 minus porosity. This cancel out. Okay. So G minus 1, that is 2.6 minus 1 into 1 minus 0.375. So this is 2.6 minus 1, 2.6 minus 1, 1.6, and 1 minus 0.375 multiplied by 1.6 is 1. So this is around 1. So this is option number C. Okay. This is question number 30. Now question number 31. Consider the following statements. Statement 1. Quicksand is a special variety of sand. No, this is a condition, not a special variety of sand. This is a condition, quicksand condition. Okay. Statement 2. Quicksand is not a material but a hydraulic condition. Yes, this statement is correct. Statement 3. In nature, quicksand condition is observed usually in coarse silt or fine sand. Yes, this is also correct statement. So 2 and 3 is correct. 2 and 3 is correct. So C will be the answer. Okay. So let me write something about this question. Quicksand condition generally occurs. Quicksand condition. Quicksand condition generally quicksand condition generally occurs in coarse silt, occurs in coarse silt or fine sand or fine fine sand, coarse silt or fine sand, not in coarse sand or gravel, not in coarse sand, not in coarse sand or gravel, because these soils are because these soils are these soils are highly pervious, highly highly pervious. These soils are highly pervious. Hence, as per Darcy's law, hence, hence, as per Darcy's law, Darcy's law, large discharge, large discharge, large discharges are required to produce, are required to produce a critical hydraulic gradient, a critical hydraulic gradient generated generated and and such flow rarely rarely but rarely materialized materialized in particle in practice in practice. Okay, so this rarely happens in soils. Okay, so option number C is the correct answer. Now question number 32. Consider the following statement. Consider the following statement. Apparent cohesion in sands is exhibited mainly due to apparent cohesion in sand is exhibited mainly due to reduction in density, increase in density, capillary moisture in pores. So apparent cohesion in sand is exhibited mainly due to increase in density. This will be the correct statement, and capillary moisture in pores, yes. 2 and 3 is the correct statement. Okay, 1 is wrong. Why I am saying this? Let me write here. Capillary moisture in pores develop negative pore water. Capillary moisture in pores develops negative pore water pressure. Negative pore water. Negative pore water pressure. Negative pore water pressure, due to which sand exhibit due to which sand exhibit apparent cohesion. Apparent apparent cohesion. Okay, apparent cohesion imparted to sand. Apparent cohesion apparent cohesion apparent cohesion imparted to sand imparted to sand imparted to sand by capillary force by capillary force by capillary forces by capillary forces also lead to sand bulking. Also lead to sand bulking, as it prevent the soil particle as it prevents the soil the soil particle from forming particles from forming a compact or stable a compact a compact or a stable compact or stable arrangement arrangement and that is why and that is why that is why volume of such a wet sand volume of such a wet sand increases increases. Hence density reduces. Hence density reduces. Hence density reduces. So in case due to bulking, density will reduce. So this will be the correct answer, not 2. So I'm again very sorry. This is density will not increase, it will reduce. Okay, so the answer will be B. So the answer will be B, not C. So this is 1 and 3 is correct. Okay, due to bulking, the density will reduce. Okay, apparent cohesion imparted the sand by capillary forces also lead to sand bulking. Due to sand bulking, the density reduces as it prevents the soil particle from forming a compact or a stable arrangement, and that is why the volume of such a wet sand increases, hence density reduces. Okay, so this is very important point. Density reduces. Okay, so option number B will be the correct answer, not C. Okay, so I'm correcting this. Option B is the correct. Reduction in density due to sand bulking. Okay, volume will increase while the mass will remain the same. So answer will be B. 1 and 3 is correct. And this is incorrect. 2 is incorrect. Okay. This is question number 32. Now question number 33. Consider the following statement. The hydraulic head at a point in the soil includes piezometric head as well as datum head. What is piezometric head? Piezometric head is nothing but pressure head plus datum head. Okay. So hydraulic head at a point in a soil includes piezometric head as well as datum head. So in piezometric head, datum head already part already a part of piezometric head. Okay, so piezometric head, it may have piezometric head is nothing but pressure head plus datum head plus datum head. So this is incorrect statement. Now second, piping in soil occurs when effective pressure becomes equal to 0. Yes, this statement is correct. Piping in soil occurs when the soil is highly porous. Piping up Piping in soil occurs when soil is highly porous. No, this is incorrect. So option number D. So let me explain this all points. So piezometric head, actually piezometric head piezometric head already includes datum head, includes datum head. Okay, and therefore statement 1 is wrong. That is piezometric head is equal to pressure head plus datum head. Next point. In soil mechanics, in soil mechanics, in soil mechanics, piezometric head, piezometric head, piezometric head. Let me write properly. Piezometric head and hydraulic head and hydraulic head are essentially the same thing, are essentially the same thing. Okay. Now, when effective stress becomes zero, effective stress become zero. This leads to this leads to erosion. This leads to erosion of the soil, of the soil, erosion of the soil. This begins this begins near the downstream, near the downstream, downstream to but downstream to but may lengthen but may lengthen progressively towards the upstream upstream. This phenomena is known as this phenomena this phenomenon is is known as piping. This phenomenon is known as piping because because erosion occurs in because erosion occurs in the form of pipe or closed channel, form of pipe or closed closed channel underneath the structure. Under that structure, the, underneath the structure, highly porous soil. Next point, highly porous soil refers to gravel. Refers refers to gravel in which in in which large discharge large discharge large discharge is required for piping piping but piping can also occur but but piping can also occurs in in sands sands which are comparatively which are comparatively larger porous larger pores and require lesser discharge and require lesser discharge. So piping in soil occurs when the soil is highly porous. So highly porous soil refers to gravel in which large discharge is required for piping. But piping can also occur in sands which are comparatively large porous, large pores and require lesser discharge. Okay, so piping in soil occurs when the soil is highly porous. So this statement is wrong. Option D is correct. So 33. Option D is correct. Okay, now question number 34. Consider the following statement. Sensitivity of natural soil deposit cannot be less than 1. Cannot be less than sensitivity of a natural soil deposit cannot be less than 1. It may be less than 1, it may be greater than 1, it may be equal to 1. So cannot be less than 1. This is incorrect. Okay. A saturated loose sand deposit liquefies when water flows through it in upward direction under critical hydraulic gradient. A saturated loose sand deposit liquefies when the water flows through it in upward direction under critical. Yes, this statement is correct. Now, statement 3. A quick clay has a very high sensitivity. A quick clay is a very high sensitivity. Yes, this statement is correct. So 2 and 3 is correct statement. So option D will be the correct answer. So what is sensitivity? Sensitivity ST is equal to unconfined strength of soil in undisturbed condition. Undisturbed condition. Undisturbed divided by QU when it is demolded. Demolded condition. Okay. So sensitivity is generally greater than 1. Sensitivity is generally greater than 1. However, it can be less than 1. However, it can be less. However, it can be less than 1. It can be less than 1 also. The stiff clay having fissures and cracks and cracks have have sensitivity less than equal to 1. Since these weaknesses are present, since these weaknesses are present in undisturbed soil, present in undisturbed soil, it will removed in remolded soil. It will removed in pre-molded soil. Okay, so it can have sensitivity. The soil can have sensitivity less than 1. Okay, and a quick clay has a very high sensitivity. Okay, so 2 and 3 is correct statement, 1 is wrong. This is question number 34. Now question number 35. Consider the following statement. The coefficient of permeability K depends on wide ratio of the soil. Yes, correct. Duration of flow. No. This is no. Next, equivalent diameter of soil grain. Yes, this is correct. Shape of the particle. Yes, this is also correct. So 1, 3, and 4. 1, 3, and 4. Option number C is the correct answer. This is K is equal to gamma W upon mu EQ divided by 1 plus E 1 upon some constant K specific surface area square. Okay, and and okay, so 1, 3, and 4 is the correct. So option number C is the correct statement. Now question number 36. A soil has a discharge velocity of this meter per second and a wide ratio of the seepage velocity. So discharge velocity or superficial velocity is V is equal to 5 into 10 to the power minus 7 meter per second. And the wide ratio E is equal to 0.50. So porosity is equal to E divided by 1 plus E is equal to 0.501 plus 0.5. So 0.5 divided by 1.5 is 1 by 3. So seepage velocity S is equal to superficial velocity by porosity. So this is 5 into 10 to the power minus 7 divided by 1 by 3 is 15 into 10 to the power minus 7. So option number A, 36, option number A will be the correct answer. Okay, this much of meter per second is the seepage velocity, and this is superficial velocity or discharge velocity. Okay, this is not the actual velocity, this is the actual velocity. This is question number 36. Now question number 37. The porosity of a certain soil sample was found to be 80%. So porosity is 80%, it is 0.8, and its specific gravity was 2.7. The specific gravity is 2.7, the critical hydraulic gradient. So critical hydraulic gradient is ICR is equal to G minus 1 into 1 minus N. So G minus 1, 2.7 minus 1 into 1 minus 0.8. So 1.7 into 0.2, 0.34. So this is option number A, 37, option number A. Now question number 38. Coefficient of permeability of an underground stratum is 0.001 meter per second. Discharge obtained from well of area is 20 meter square dug into a stratum with drawdown of 2 meter. So drawdown 2 meter, that is I is equal to 2. Drawdown is 2 meter. So you can take I as 2. Okay, so Q is equal to Ki into A. So K is 0.001 into I is 2 into A is A is 20. Okay, so uh, this is 40. 40 into 10 to the power minus 3 meters cube per second. When you convert this in liter, so it is per minute. So 40 into 10 to the power minus 3 into 60 into 60 and into 1000. So this is liter per minute. So this is 2400 liter per minute. So option number A. So this is with drawdown of 2 meter. That is, drawdown is nothing but the head loss per unit length. So head loss per unit length, actually this is the drawdown. So this is 2 meter drawdown. There is 2 meter drawdown per unit length. We move in this direction. So there I is equal to 2. Okay. So I is equal to 2. And the surface area of well is surface area, this peripheral surface area. Okay. You take this surface area. Okay. This is 20 meters squared. So this is A. I given, K given. So you can calculate Q. Simple. This is 2400 liter per meter per minute. Okay. So question number 38. Now question number 39. Consider the following statement. Organic matter decreases the permeability of soil. Yes, this statement is correct. Entrapped air decreases the permeability. Yes, this statement is also correct. So option number C will be the answer. 39. C will be the answer. Okay. Now question number 40. Statement 1. When a tube well uh, penetrates into a homogeneous aquifer and is then pumped, there will occur lowering of water surface. The resultant surface is designated as drawdown curve. Yes, this is correct statement. 40. Now, since the pressure on the surface of drawdown curve is always at atmospheric level, it is called by this name. No, this statement is incorrect. There is no relation of this name and the pressure is atmospheric. And this is incorrect statement. So option C will be the correct. This is question number 40. Now question number 41. Consider the following statement. Presence of moisture in sand does not affect the magnitude of friction angle. Yes, this statement is correct. Now moisture introduces capillary effect in a sandy soil, leading to apparent increase in angle of internal friction. No, this is incorrect statement. Moisture introduces capillary effect in a sandy soil, leading to development of apparent cohesion. Yes, this statement is correct. The capillary film is broken by drying of submergence, leading to loss in the apparent cohesion. Yes, statement is also correct. So 1 is correct, 3 is correct, and 4 is correct. So in these options, you can consider 3 and 4 correct. Okay. So D will be the answer. D will be the answer because 1, there is no 1 with 3 and 4. There is no 1 with 3 and 4 in this option. So the most appropriate answer will be D. Okay, this is question number 41. Now question number 42. The water ratio of a given soil A is twice that the another soil B, while the effective size of particle of soil A is 1/3 of that soil B. The ratio of height of capillary rise of water in soil A to that of soil B will be. So height of capillary in terms of the void ratio and the size, effective size is some constant divided by E D10. So EA, the void ratio of soil A is twice that of soil B. So EA, this is equal to 2 times EB, while the effective size of particle A is one third of that of, so D10A, D10A is one third D10B. The ratio of height of capillary, okay. So the ratio is HA by HP is equal to HA by HP is equal to EB D10B divided by EA D10A. So EB is EB D10B divided by E is 2EB into D10A is 1 by 3 D10B. So this is 3 by 2 is 1.5. So option number C will be the answer. So 42, option C will be the answer. In this formula, HC divided by E D10 HC, H is what? H is height of capillary rise. Height of capillary rise. E is what? E is void ratio. Void ratio. D10. D10 is effective size of soil particle. Effective size of soil particle. Soil. Effective size of soil particle. And C is an empirical constant. It will lie from 0.1 to 0.5 centimeters square. Okay. So this is option number C is the correct answer. Now question number 43. So this question we'll discuss tomorrow. So this is all for today. Thank you.